Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students. Welcome back to this TV Learning Series program. Teacher Patrick will be with you today, and I'll be with Senior 6. We are still talking about the Unit 5. If you remember, that's what we were talking about even last time. We are still on the derivatives of the benzene. And our lesson will look at the chemical properties of the methyl benzene. Methyl benzene is one of those derivatives of the benzene. So that is what we are just looking at. And by the end of our lesson today, I hope you are with me and you are ready we go together. So by the end of the day, by the end of the lesson, we look at the reactions that destroy the pi system of the benzene ring. Those are the reactions of the methyl benzene, to be precise. And we look at the side chain, or I've written chain twice. So the side chain reactions of methyl benzene. So that is what we are also going to look at. And then we look at the electrophilic substitution reactions of the benzene ring. So we had looked at this one before with the benzene. If you still remember, we had seen this one before. I hope you still remember what we looked at in the electrophilic substitution of the benzene. But this time, we are looking at this electrophilic substitution of the methyl benzene, or taurine, which is one of the derivatives of the benzene. So before we look at the reactions that destroy the pi system of the benzene ring, let's first go through together. In the previous lesson, we looked at the effects of the substituents on the benzene ring, if you remember very well. We talked about these, the effects of the substituents. What happens if a benzene ring contains another substituent or group of atoms? So this is what we are going to look at. Now, this is what we are just going to revise together. If you remember very well, we talked about these two terms are not new terms. We talked about the deactivating, and then we have talked about the activating groups. So there are two substituents, two types of substituents, if you remember. We said a substituent, that is a group of atoms or an atom that is attached on the benzene ring. If we consider the benzene ring with its pi system, if we have this X is either deactivating or activating. That means deactivating, reducing the reactivity of the benzene ring towards the electrophiles. Or activating, that means increasing the reactivity of the benzene ring towards the electrophiles. So we said either X can be deactivating or X can be activating, depending on the nature of this X. And mainly, there are two, how you can identify this. So the question is saying, predict with reasons which of the following groups of atoms attached on the benzene ring would act as deactivating or activating. So these are the groups. So you have the nitro group, you have the methyl group, you have the carboxylic group, and you have the OH group. So you need to determine which of these ones is activating or deactivating. Let's start with the nitro group. So you will not be able to identify this unless you draw the structure of these compounds, unless you draw the structure of these groups of the molecules that are attached on the benzene ring. So if we draw the structure, this would look like you have the oxygen. This is the single bond, and you have the double bond here with the oxygen. So molecules, take note of this, please. Molecules which are uncirculated. What do I mean by uncirculated? They contain a double bond, or they may contain a multiple bond. And it is attached on the benzene ring. That molecule is said to be deactivating. So the molecule has to be uncirculated. It has uncirculated, having either a multiple bond, double bond, or triple bond. So this one has a double bond. Or, another important note that you should not forget, it must have a positive charge. The formal charge of this nitrogen is the formal charge is positive. So if the group, the atom that is attached on the benzene ring contains a positive charge, or it is uncirculated, then you will have, it will be a deactivating group. We may have, this is a methyl. Methyl groups are, if we have the methyl groups are the activating groups. They usually donate the electrons towards the, so if you have the methyl group, this is the methyl group, and is attached to the benzene ring. So it will always push the electrons towards. That is, we call it positive inductive effect. If you remember the alkyl halides, that word comes again. Positive inductive effect. So they donate, so meaning that the methyl group here is activating because it increases the electron density towards the in the benzene ring, in the pi system of the benzene ring. Look at this one. This is a carboxylic group. This carboxylic group is also, this is the structure of the carboxylic group. So it is also uncirculated. So it will form, this one will form a positive charge, and therefore electrons will tend to move from the benzene ring. So they get out of the ring. And that is why you say this one is deactivating. Deactivating, this one here. Deactivating. Deactivating group. So it reduces the electron density, or the reactivity of the benzene ring towards the electrophiles. So we have this OH. So this OH has got this is circulated. This is uncirculated. This one is neither of those ones. But we said this one is, it has the tendency of pushing the electrons towards the benzene ring. So the OH has got the lone pairs. So we talk about the lone pairs of the electrons, the lone pairs OH with the lone pairs here. So these lone pairs tend to move inside here, and therefore if they are entering into the ring, what does that mean? It means that the reactivity, it increases the electron density within the ring, and that means increases the reactivity of the ring towards the electrophiles. That is, so this one is activating. Activating. So that is what, this is just a reminder of the previous, I just wanted us to still recall about these two terms as we go along, because the derivatives will depend on this. All the chemical reactions and whatever we are going to talk about will depend on these two. That is why I wanted us to go back a little bit and then remind ourselves about those terms that we mentioned in the previous lesson. So right away, let's go to the reactions that destroy the pi system of the benzene ring. One of the reactions that destroy, that is, we are starting with the reactions, is combustion. So when we talk about the combustion, we are talking about the reaction with oxygen, and that is methylbenzene C6H5CH3, that is the molecular formula, plus oxygen This one will give us the carbon dioxide plus water. Remember, these compounds, all the compounds of the benzene, all the compounds that contain the benzene ring, when they burn in air, because of high carbon content, they produce a smoky flame. That means including some particles of carbon due to incomplete combustion. So that is the reaction we are talking about, combustion. Then we'll talk about the hydrogenation. So hydrogenation is similar to, if you remember about the alkenes, this reaction was there in multiple bond compounds and hydrocarbon atoms with multiple bonds. So benzene, methyl benzene, reacts with hydrogen, the 3 moles of hydrogen, in presence of nickel catalyst at 150. So the benzene is this one that is destroyed. That is what I was talking about. So the double bonds within the benzene, those double bonds, the pi system is destroyed, and then it forms cyclohexane. I think we had looked at this one even before. So this forms cyclohexane. These are some of the reactions that destroy the pi system of the benzene ring. This one is more reactive than the benzene. So this methyl benzene is more reactive. That's what you should take note of, that it is more reactive than benzene. And therefore, this reaction, the conditions may be slightly different from those ones of the benzene. You remember when we are using the benzene, we used Ranne nickel. I talked about that one before. So right away, those are the 2 reactions that destroy the pi system of the benzene ring. So let's look at the side chain. In the side chain reactions, we have the first one is halogenation. Halogenation, that either addition of bromine or addition of chlorine to the methyl benzene. The side chain we are talking about is the methyl group. So that means this is the side chain. So the reaction takes place here. So this reacts with chlorine in the presence of UV. Remember this reaction with hydrocarbons? If you remember this reaction with hydrocarbons, alkanes. What was the name of this reaction? Free radical substitution reaction. So this is what happens. Now, chlorine plus hydrogen chloride. So the reaction continuously takes place until all the hydrogens are being substituted. So this will be CH2 chlorine plus the chlorine molecule in presence of UV. So you'll have CH2 chlorine plus hydrogen chloride. And then finally, you will have, this is CH2 chlorine plus another chlorine in presence of UV. You'll have to get all the hydrogens are being substituted. So you'll have CCr3 plus hydrogen chloride. So this is free radical substitution. Please, whenever you are writing the benzene, make sure you remember to put the pi system because the compound will be quite different. So this undergoes what we call free radical substitution reaction. Or that is the mechanism, or we can call it photochemical reaction. Photochemical reaction. So it takes place in the presence of light, as one of the conditions for that reaction. So side chain, among the side chain, we have, so the mechanism, if you remember, the mechanism involves the initiation step. It involves, if you remember very well, this is just involves propagation. And then it involves, again, termination. So these three steps, if you remember, go back to the alkanes and see how this reaction takes place. And it is the same reaction that you will have when you look at the reactions, which are these reactions, and if you follow the same steps, initiation, propagation, and termination, you will be able to do the mechanism. And that is why I'm leaving it out for the meantime. Then I will please work it out and see whether we'll have the same answers. In the next lesson, I will come and then I will talk about it in details. That is when you'll have looked at it and then compare it with the other one of the alkanes for free radical substitution reaction. So another reaction that we have to look at in the side chain is the oxidation. The oxidation. Oxidation involves the addition of the oxygen or the removal of the hydrogen. So methyl benzene can be oxidized, or when it is refluxed with the potassium permanganate acidified, or potassium dichromate also acidified, you will get benzoic acid. You will get the benzoic acid. So that is the reaction. This reaction, take note of this one. This reaction can be used to distinguish between methyl benzene and benzene. Methyl benzene and benzene can be distinguished by using potassium permanganate in acidic conditions or potassium dichromate in acidic conditions. And this is what happens. The observation, we had talked about even this one, if you remember the alcohols, you remember the carboxylic acids. We talked about these reactions of potassium. These are strong oxidizing agents. So it can be used to distinguish between benzene and methyl benzene. How is it used to distinguish between these two compounds? Methyl benzene gives a positive taste. I mean, potassium permanganate, which is purple, will turn into colorless. Potassium dichromate, which is orange, will turn into green. But when these reagents are subjected to, or they are reacted with the benzene ring, no observable change. So that is very important note to remember with the methyl benzene. I said this reaction is used to distinguish, that is why I'm repeating it, is used to distinguish methyl benzene and benzene. And I said how? The observations that are given. Potassium permanganate, which is purple, when it is reacted with methyl benzene, the potassium, the purple color disappears, or it turns into colorless. When potassium dichromate is used, then you will have the green, the yellow color, yellow-orange color, turning into green with methyl orange. With benzene, no observable change. The tests are negative. So that's why I'm repeating it, that you should not forget that. So another important reaction, or something I want to talk about, the oxidation. These are the oxidizing agents. But the mild oxidizing agents, I mean the weak oxidizing agents, oxidizes the methyl group into an aldehyde. It oxidizes, instead of the carboxylic acid, it will be oxidized to an aldehyde. So this is what happens. If you have a methyl group, and then you are adding either one of the, or mild oxidizing agent is manganese 4 oxide, or you have chromium dichloride dioxide. Those are mild oxidizing agents. So when they are subjected to this, then you will get, instead of moving to the carboxylic acid, you will move to an aldehyde, COH. So that is benzaldehyde. That is when you are using mild oxidizing agents or weak oxidizing agents. So let's look at some other reactions, electrophilic substitution reactions. So with electrophilic substitutions, I hope you have taken note of this. I'm sorry, I have to remove this so that you can get space. Electrophilic substitution reactions, as I said earlier, we are looking at these reactions. We had looked at these reactions even before. So when we are talking about these electrophilic substitution reactions, we are talking about the concentrated nitric acid, that is the nitration. And we looked at the same reaction. Nitration, we looked at, that is methyl. I've just summarized them here. We have the methyl benzene with the concentrated nitric acid and concentrated sulfuric acid at 30 degrees. Remember, with benzene, we are using 50 to 55 degrees Celsius. So the temperatures have reduced. Why do you think so? Why do you think the temperatures have reduced? Just 5 seconds to think about that. Good. The temperatures have reduced because this methyl benzene is more reactive. Because we have said the methyl group is an activator. It increases the electron density within the ring and therefore increases the reactivity of the pi electrons towards the electrophiles. And that is why the temperatures are reducing. And remember what we said, the methyl groups being an activator, those molecules that activate the ring, dilect other orientation, other substituents to position 2 and position 4. That's why we are getting 2-nitromethylbenzene or 2-nitrotaurin, or we are getting 4-nitromethylbenzene. When you look at the fuming sulfuric acid, so we looked at the same reaction with benzene. Similarly, the temperatures here were 80 degrees, if you remember, 80 degrees, but the reaction now is at 0 degrees. It is at 0 degrees. That is the reaction because of this activator, increasing the reactivity of this. So that's why the conditions are lowering. To 2 and 4, remember the positions. The ortho and para positions. When you look at do you remember the type of reaction that we talked about? This is a special type of reaction. This one here, this is archylation. This is archylation, this is acylation, which we said these were discovered by the Friedel-Crafts. Friedel-Crafts, those are 2. You remember I talked about them. James Friedel, and we talked about the Mason Crafts. So those 2, discovered these reactions. What is very important to remember is to take note of the positions where the alkyl and the acyl groups are attached. Position number 2, number 4. Number 2, number 4. Those are indicating the para and ortho, the ortho and para positions. Ortho for 2, para for 4. So that is why we need such summary, because if you remember the mechanism, let me take an example of this. Methyl benzene with reacting with chlorine in presence of aluminum chloride. So this one will be also the substitution. So the methyl benzene. So you'll get the chlorine plus on position number 4. So you have the methyl benzene and then chlorine. So this is still the same reactions, which is similar to this. So the halogenation. So that is why I would ask you to record the mechanism. The mechanism is the same with the benzene. If you remember, the only difference here is the positions where these substituents have to be attached. The para and the ortho and the para positions. So I would like to end our lesson here, but before I leave, I just want to take you through the homework. Try this, please. The scheme below shows some reactions starting with methyl benzene. I extracted this question from a national exam papers. I don't remember the year, but if you can check in those papers, then you can still get the same question, because that is where I extracted this question. Methyl benzene has a nitro group. This is step. I have to make that one clear. So this one is moving to this side. And this one is also moving to that side. I hope it is very clear. And then this is step number 4. This is step number 2. Number 3. Give reagents and conditions used to carry out reactions 1, 2, and 3. 1, 2, and 3. So you give the conditions and the reagents. What type of reaction is step 4? What is this type of reaction? I hope we have not seen this one, but you try to check out in some of you who have the books. You will find it there. Give the structural formula for compound A. Compound A is here. What is the name of the mechanism involved in Roman 1, step number 1? Roman 2, step number 2. So those are the mechanisms. What are those the mechanisms involved? I wish to stop here for today. I hope you've been with me. Thank you so much for being with me. And thank you so much for listening and watching. We meet together in the next lesson. Bye-bye.